Hello and welcome to POWTECH Virtual Talks. Today we are talking about food goes powdered. Matthias Böning from amixon is going to have a speech on ready-to-bake mixtures with liquid additions. Enjoy and have fun.
Thank you very much. Yes, it's nice to be here. My name is Matthias Böning. I'm one of the managing directors and responsible for the sales department. I'm more than 20 years with amixon. I welcome you, ladies and gentlemen, very warmly. I would like to refer about the ready-to-bake mixtures with liquid additions. The rapid growth of the world's population requires solutions to make food production not only more productive, but also safer. For all the need for efficient food production to adequately feed a large number of people, food safety must not be neglected under any circumstances. amixon mixing systems come into the game here, ensuring the perfect balance between performance, safety, and taste. Manufactured in Germany, equipped with hygienically optimized property technology and individual tailor-made executions fulfilling the specifications of your products, amixon offers modern processing solutions for the food industry. The content of my presentation is structured as follows. First, I will explain some details about my company amixon. Then I briefly show the functionality of vertical precision mixes. After that, I will go into detail on the subject of adding liquids to powder mixtures and show possible solutions. Finally, some examples from practice will follow. A few words in advance about my company amixon. In the industrial area in the south of Paderborn, 150 people are employed. They are experts in manufacturing of mixers, vacuum dryers, and synthesis reactors for dry, moist, and suspended solids. Manufacturing takes place only in Paderborn in Germany. We really could say these mixers, dryers, and reactors are made in Germany. The test facilities with trial machines, however, are located everywhere. Excuse me, that was too fast. Everywhere in the important markets. With the company introduction and the first slide, I may do a little advertising. So I mention here our latest development. It concerns a precision mixer with the sizes from 5 to approximately 80 cubic meters, which has the name Gyroton. This mixer can ideally precisely homogenize large volumes with particularly low, very low drive power if a mixing time of, for example, 15 to 40 minutes could be accepted by the operator. amixon is a synonymous for vertical mounted mixing tools in cylindrical mixer vessels, as you can see here. The mixing system was launched in 1983 when the company was founded. About 25 patents describe a variety of features and their user advantages. The bottom of the vessel is either flat or conical in shape. These apparatus are stationary mixers. Our product range also includes container mixers, vacuum dryers, and pressure-resistant synthesis reactors. Inside a cylindrical mixing vessel, we see a helical blade mixing tool, which is driven and supported centrally only from above. Feeding takes place from above too. Emptying of the mixer, goods take place below by opening a flap. This flap closes coplanar with the plane of the mixing chamber bottom. This is a specially designed valve that opens and closes electropneumatically inside a standard flange. All components in contact with product are carefully welded and grinded. This applies also to the mixing tool. Shovel-like arms support the mixing tool spiral, which is manufactured here in a concave design. You can see that here on the picture. In contrast to the standard helix, which has an inclination of only 18 to 25 degrees, concave or convex helixes can have much greater inclinations without any disadvantages in mixing technology. The patented designs, on the other hand, have excellent residual emptying properties. Please let us take together a look on the mixing process. Please follow the movement of one single particle, agitated by rotating mixer arm. We see that the particle follows the forced movement of the arm, but at the same time it also moves from the inside to the outside. The path of motion is similar to that of a logarithmic spiral. Once the particle reaches the periphery, it is grabbed by the helical band and screwed upwards. Once at the top, the goods move to the center and from here flow back to the bottom. Then the goods move again rapidly from the inside to the outside and screwed upwards again. If desired, the radial drift can be favored by the special shape of the mixer arm. For example, in order to stream poorly flowing goods more intensively, in addition, chopper tools can be used to desagglomerate agglomerates or to round particles. See them here on the left side. It is nevertheless possible to give the bottom of the single shaft mixer a conical shape. The flow effect is identical. Here also the upward flow takes place in the periphery of the mixing chamber, and the downward movement again due to gravity occurs in the center. The minimum filling level for homogenization is approximate 5 to 15% only. Desagglomeration and increased energy input with chopper tools also works effectively at low filling levels, here in the conical parts. This mixing tool is also welded without joints and is supported only at the top and meets the highest hygienic requirements. If we look here to the twin shaft mixer, it is also possible to move two single shaft mixers inside each other. Then both mixing tools rotate in the same direction and allow a very special space controlling flow. Let's look together at some hygienic features. You see here a thick-walled vessel which is cut by a water jet resulting from 4,000 bar pressure. If the cut is made with a constant slope, then the corresponding reveal can be used for sealing purposes. In the movable part, the door, a groove is provided which receives a round seal. You see that here in the video. The door is pressed into the seal with so-called quick clamp systems. Quick clamps of this type are self-locking, particularly hygienic, and easy to operate. I had previously explained that the mixing system achieves technical ideal mixing grades in a short time. In addition, it can empty itself almost completely when the materials are free-flowing. The helical mixing tool has a strong convexity, you see it here, in addition to the helix inclination. Thus, the vectorial sum of both slopes is greater than 33 degrees at any point. And in this respect, it is ideally suited to ensure that the mixed residues flow downwards automatically from the mixing tool during the discharging process. In the next slide, I would like to tell you, ladies and gentlemen, about problems and solutions resulted from liquid additions to powder mixtures. One example for the preparation of highly concentrated baking premixes, there's often a high liquid loading necessary or required, so that the powders lose a large part of their flowability. Impregnation could avoid losing of flowability. Impregnation means that we allow the liquid additions to take place in the vacuum mixer. After the uniform distribution has taken place, the pressure is slowly increased up to ambient pressure. In this respect, the liquid phase penetrates deeply into the porosity of the particles. It is then removed from the surface of the powders. And this ensures at the end a better flowability of the product, but also a reduction of dust. Both together are important advantages for the packaging process afterwards. Here we see exemplary ingredients as they occur in the baking industry as liquid additives. The powder mixer should remain as clean as possible, and the liquid ingredients should be distributed completely and evenly in the powder. The process is not trivial. The degree of difficulty of agglomerate-free mixing increases in the direction of the arrow. Depending on the quality of lecithin or oleoresin, its fine distribution in the baking powder can be particularly difficult, especially if the powders have high fines content or have particularly absorbent properties. In such a case, we will first try to reduce the viscosity of the liquid. An effective method is to heat it beforehand. This often significantly facilitates the distribution. Viscosity, as we know, is a measure of the viscosity of a liquid. A highly viscous substance flows only slowly and is difficult to spray with a nozzle. The viscosity can be influenced to a large extent by the temperature. Worth mentioning, it seems to me, is an optimization work by the ladies Blumen and Richter from the Martin Braun company, where the distribution of fats in baking agent is concerned. Here, palm fat was heated from the aim of reducing the viscosity and then cooled after a certain dwell time. During this process, the reduced viscosity remains and then increases again after a significant delay. This hysteresis, the change in viscosity follows the change in temperature with a significant delay, permits convenient homogeneous distribution of the palm fat with extremely low heating tinting. The baking agent remains cold and has good free-flowing properties at the end. It is certainly possible to pour the liquid materials into the mixer from above. That is very simple. However, it is much more effective and cleaner to add the liquids over a longer mixing period, as shown here in the form of an injection into the effective area of the high-speed cutting rotor. The intensive distribution already takes place at the time of addition. High concentration differences are avoided, and the mixing chamber, the tools, remains clean. Another possibility is to use a two-substance nozzle, or better, an atomizing nozzle, which fluidizes the mix of gas and liquid in the mouth area of the nozzle and atomizes the liquid into very fine drops. The drop size is between 15 and 30 microns only. In this way, the liquid hits the powder, which is in a state of particularly high porosity, in the form of finely atomized droplets. an ideal condition for the mixing process. I would like to show you some examples from practice. If we look here at the mixing task, and we see different ingredients, and we look for a ready-to-use mixes with success guarantee. The process is as follows. During filling, the mixer stands still, or the mixing tool rotates very slowly. Whereas the mixing takes place after addition of the basic ingredients. Liquids like fat, oil, shortenings, bakery extracts are fed into the mixer automatically. Then the mixing tool stops. If fragile items are to be added, the main mixing tool starts slowly and operates for some seconds. What are the main advantages? The mixture is perfectly homogeneous, that's for sure. It's free-flowing, no impact by heat from the mixing action. That means also easy to pack. Low in adhesion. Coarse pieces and fruits look natural, fresh, and undamaged. Mixing time is very short. Mixing and discharging can take place in a protective gas atmosphere if that is requested or required. The mixing process here, if we look for seed mixing cereals and muesli, is carried out very gently at widely varying filling levels. The mixing tool turns with an exceptionally low rotational speed. The energy input, and that is very important, is very, very low. The advantages here is we get a homogeneous mixture result despite of large differences with, in regardless of bulk density and particle size. The mixing is very fast and gently. It is perfectly homogeneous. The particles are undamaged, and that is very important for this muesli recipes. To show you that a little bit more in detail, we took some videos in our test lab center. That videos are related to a mixer with 2000 liters. We fed in all the ingredients. In the first one, we have strawberries, blueberries, freeze-dried particles, very light and fragile, oatmeal and cornflakes. In the second, we have some crunchies, raspberries, blueberries, and oatmeal. And in the last one, we have some crunchies, coconut flakes, oatmeal, and honey powder. And you see that we get a very good homogeneity after a few seconds of mixing only. That is very important for such a production process, especially if we look for biomuesli producers. They are very often mixing by hand or using a container system. But to do it more effectively and with higher volumes, we were also requested many years ago to do it with such a twin drift mixer with a lot of success for this runnings here. And you see we do not create any dust or something else, so we are not destroying the particles. And that is only possible by a very short mixing time. Another mixing task is that you would like to do a coating process by fat. The mixing and deagglomerating and shearing of sugar, block fat or melted fat takes place with a high energy input. The main mixing tools and high shear blades are used at high speed. Finally, the mixture is cooled cryogenically by introduction of liquid nitrogen into the mixing chamber, for example. Looking at the main advantages here, every particle is coated with fat. We could reach degrees of more than 99% of coating. The mixture is hydrophobic, dust-free, easy to pack, free-flowing, not impacted by heat from the mixing action, and looks identically to decorating sugar, for example. And here's the last process I would like to show to you. The flour is, we look here for the toasting of flour and deactivation of enzymes and preparation, for example, of starch derivatives. Process of flour is placed in the mixer, then the mixing tool is started, the mixing chamber and mixing tools are heated. That is very important so that we have no cold areas remaining. The exhaust vapors are discharged at ambient or vacuum atmosphere. Optionally, the mixture is flooded with dry gases while mixing. If required, liquid additives are mixed in using an atomizing nozzle, as shown before. What are the main advantages using an amixon system? The toasted flour has particularly good instant properties. Excess water content is evaporated quickly and effectively. The powder is free of lumps, and optional, the flour has a roasted flavor, mixes and disperses well with liquid. So, thank you very much for your attention and interest. I think I'm in time, yes, and so I'm available for your questions now.
Hello, thank you very much, Mr. Böning. We have one question, I think, in the chat. Let's have a look. Jürgen Böx is asking, could you maybe briefly explain how your continuous dry mixer works? Is it truly continuous or intermittent mini batch?
Drying is every time here intermediate, so in batch. It's not really a continuous process.
Okay. Any other questions? Professor Barnico, would you like also to jump in, perhaps? And I have two questions here. Just 1 second, I have to. So I have two questions here. What is the standard mixing time, including liquid additions, with the focus on minimalized energy input?
That is a good question. That is always related to the powder recipes as well. As I said, for the muesli recipes, the mixing time is only a few seconds, 15 to 20 seconds. If we have to add some larger content of liquids like molten fat, for example, with 10, 15, or even sometimes 25 and 30%, then such a mixing process can take also 5-10 minutes at all. But that is really related to the recipe itself.
Okay.
And everybody is welcome to visit us here in Paderborn. We have a very nice test lab center where we have mixers available from 5 to 2,000 liters. Also, a 2,000 liter mixer can be used for test trials. And we could rent such machineries also worldwide to our customers.
I think Paderborn is a good place to be for this kind of topic, definitely.
Absolutely, example.
Mr. Böning, there is Peter Gustafsson. But I think perhaps you have answered the question already. How long time does a CIP cycle take?
A CIP cycle, we are doing CIP very often here also in the test lab center, and I can say one cycle for CIP cleaning is most times 3 to 6 minutes. That is always enough to do a good cleaning of a mixer. Afterward, you have to wait for a few seconds for drying, and because if you're using hot water with 80-85 degrees Celsius, the drying process takes place very quickly. And afterward, then you have to wait for a certain time that the mixer and the mixing chamber cools down again, especially if the next product has some fat powder in. You are not able to feed in your material if the vessel temperature is higher than 30 degrees, for example.
Okay. One more question. Gentle mixing and mixing with a high energy input. Which are the solutions and possibilities a vertical mixer could provide?
Very good question. The answer is very simple. With a vertical mixer, you can fulfill both. You can have a very gentle mixing process on the one hand, only with the main mixing tool. But on the other hand, if you add some additional tools like the cutting rotor, we could add also a lot of energy input. By adding maybe 1, 2, or 3 cutting rotors, we could increase this level of energy input as well. And so we could mix very gentle muesli recipes, but on the other hand, we could add also some block fats or molten fats in a very high content by using this cutting rotors.
Thank you.
You're welcome.
If there are no more questions from our side, thank you so much. Thank you to all of you speakers. All the speakers can be contacted directly, or you can write us directly to POWTECH, and we will forward your message to the speakers. We will have the videos available online next week. So everyone who would like to rewatch, or if you would like to share with someone, definitely you are free to do so. We have a LinkedIn and a Twitter account where all news on those topics and on upcoming virtual talks are always posted. And of course, if you have anything you would like to tell us, feel free to do so. Thank you for listening. Thank you to Professor Barnico, who is our co-host, and to the University of Applied Science and Arts, and we from POWTECH team, and I think also Beate Fischer is unmuted right now, so perhaps she would like to say something as well.
Yes, thank you. Thank you all of our speakers and to Professor Barnico, and I wish all to you a happy Easter. And I hope we see us in the end of April to the same topic, not the same, but the different.
Same, but different, I would say.
Yeah.
Thank you so much. Have a great day. Enjoy. Have a great Easter holiday if you have holidays. And we are glad to hear from you. Glad to get some feedback or questions or anything. Thank you so much. Thank you, Mr. Böning.